friends, in this new video we discuss an important property of divisibility by number 11 and number 9. Number is 2572. Then actually its expansion is like this: 2 is a unit place, 7 is at 10 place, 5 is at 100 place, and 2 is at 1000 place. So it is like this: 2 into 10 cube plus 5 10 square plus 7 into 10 plus 2. Or if we take a very small number, suppose 53, then the place of the 5 is a 10, and hence we have 5 into 10 plus 3, like this. So whatever may be the number, we can write it in terms of these polynomial expressions, and these are the coefficients of this polynomial: 2, 5, 7 and 2. These are the coefficients, and these coefficients are come from digit 0 to 9. These are the digit which will come in these polynomials. That means every number contain these 9 digit, whatever may be the bigger number is that. For example, if we have a bigger number, let us take more bigger number: 999725573, this one. Then the polynomial expression, this number is actually like 3 plus 7 into 10 plus 5 into 10 square plus 2 into 10 cube plus 7 into 10 raised to 4 plus 9 into 10 raised to 5 plus 9 into 10 raised to 6 plus 9 into 10 raised to 7. And look at this. So this is a polynomial where the polynomial, and this is a polynomial in 10, and these are the coefficient of the polynomial. So if we take the general case, suppose n is the number where this is a m into 10 raised to m plus a m minus 1 10 raised to m minus 1 plus 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 a1 10 plus a0. This is the polynomial expression of the number where the coefficients a1 a2 a0 a1 a2 and am, these are the coefficients of this polynomial, and these coefficients vary from 0 to 9, 0 less than equal to ak less than equal to 9. Okay, so these are the coefficients and varies from 0 to k is equal to 0 to m. Then friends, this polynomial, suppose this is a polynomial, then we know that if we have a polynomial p of x, this is equal to, suppose, summation ax ak x raised to k equal to 0 to m, and we know that 10 is congruences to 1 modulo 9, 10 is congruences to 1 modulo 9. Then we have proved that if a congruences to b modulo n, then the polynomial p of a congruences to p of b modulo n. So here we can write p of 10 congruences to p of 1 modulo 9. Now what is my p of 10? P of 10, this is a polynomial. Let us take expansion of this. This is ak x raised to am x raised to m plus a m minus 1 x raised to m minus 1 plus 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 a1 x plus a0. This is a polynomial p of x. Then p of 10 equal to a m 10 raised to m plus a m minus 1 10 raised to m minus 1 plus a1 10 plus a0. So it is a number capital N, and p of 1 equal to am plus am minus 1 plus a1 plus a0. Let us call this as a yes. Okay, now this gives us that this n is congruences to s modulo 9. Okay, and we know that if p of a is a solution, that means p of a congruences to 0 modulo n, then p of b is also a solution of this polynomial p of b congruences to n 0 modulo n. So that if s congruences to 0 modulo 9, then n is also congruences to 0 modulo 9. That means, in other word, if s is divisible by 9, then n is also divisible by 9. This is the important point which we got here. That is, if 9 divides yes, then 9 divides 9, whatever may be the number. Okay, that means we do not need to check the whatever may be the greater number. We have to just take the sum of this coefficient am minus 1 plus a1 plus a0, and that is called as yes. For example, if we take a number 3, 5, 2, 7, and I want to check whether this is divisible by 9, then that we do not need to carry out the lengthy division process by 9. I will sum this. That means 3 plus 5 plus 7 plus 2 plus 7 equal to 3 plus 5 8, 8 plus 2 7, 8 plus 2 8, 10, 10 plus 7, 10 plus 7 is 17, and 17 is not divisible by 9, and therefore this 9 is not a divisor of yes. Hence 9 is not divisor of 3, 5 to 7. This is the important point which we have we get from this theorem. So this is the proof. If we take the number n, consider the polynomial p of x, then we know that 10 is congruences to 1 modulo 9, p of 10 congruences to p of 1 modulo 9. Then this number p of 10 is nothing but n, and p of 1 we called it as a s. So whenever this s is divisible by 9, then 9 is the number n is also divisible by 9, and conversely, if n is divisible by 9, this s is also divisible by 9. I will write the statement of this theorem, and we will apply the same criteria of the checking to the another digit, that is another number, that is 11. So if n equal to am 10 raised to m plus a1 10 plus a0, this is my number. B, the decimal expansion of the positive integer n 0 less than equal to ak less than equal to 10 less than 9, or here less than 10, we will follow the theorem as it is, and let s equal to a0 plus a1 plus am, then 9 divide n if and only if 9 divide yes. So this is the statement of the theorem which shows that if 9 divide n, then 9 divide yes. If 9 divide yes, then 9 also divides n. Now let us take the same criteria for another number. Let us, that means we know that 11 is a divisor of 11. Okay. Here you can take 10 is congruence is to minus 1 modulo 11, right? What is a 10 congruence to 11? This is 10 minus of minus 1, that is 11, and 11 is divisible by 11. Then p of 10 congruence is to p of minus 1 modulo 11. P of 10 is known to us, which it is already we have calculated. P of 10 is nothing but capital N, and let us calculate the value of P of minus 1. Let us put that value here. You can see that P of minus 1 equal to, we have a0 x a1 x is minus 1, so we have a1 plus a2 x square, that is, I will write once again the same polynomial in terms of x so that you will get the clear idea. Let us start from a0 plus a1 minus 1 plus a2 minus 1 square plus a3 minus 1 cube plus am minus 1 raised to m, right? This is equal to a0 minus a1 plus a2 minus a3 plus minus 1 raised to m into am. Let us call this is as a t. So we have n congruence is to t modulo 11, and therefore if t congruence is to 0 modulo 11, we have n congruence is to 0 modulo 11, and hence we can write the same theorem in for 11 also. Whenever the t is divisible by 11, then n is also divisible by 11. What is my t? Like here, yes, t is equal to, where t equal to a0 minus a1 plus a2 minus a3 plus minus 1 raised to m into am. Then this instead of 9 we have 11 is divisor of 11 if and n if and only if 11 is a divisor of t. So this is the another theorem which we get from the integer 11. Let us take one example of this and we check that whether the theorem is true or what will be the result. Let us suppose that we want to check whether the big number 724 is divisible by 9 and or divisible by 11. Okay. So let us take what is a yes. S is 1 plus 5 plus 7 plus 1 plus 7 plus 2 plus 4 equal to 1 plus 5 6, 6 plus 7 13, 14, 21, 21 plus 2 23, 23 plus 4 27, and 9 is a divisor of 27, and therefore 9 is a divisor of 1 5 7 1 7 2 4, this big number. Now t equal to t equal to 4 minus 4 minus 2 plus 7 minus 1 plus 7 minus 5 plus 7 minus 5 plus 1. This is our t. Then look at this, we have 2 plus 7, 2 plus 7 9, 9 minus 1, 9 minus 1 8, 8 plus 7, 8 plus 7 15, 15 minus 5, 15 minus 5 10, 10 plus 1 11, and here 11 is a divisor of 11, and therefore 11 is also divisor of 1571724. So we get this. The result is a very useful for checking the divisibility directly, or in a very quick, in a very few seconds we can calculate whether the given number is divisible by 11. We can check whether it is divisible by 11 or not, whether it is divisible by 9 or not.